We are going to titrate a strong acid with a strong base in this titration. And I think I'm just going to start by looking at the general titration curve. We have a strong acid, and we're going to add milliliters of strong base, or NaOH. Because we have a strong acid, we have a very low pH, and I'm adding base, but I still have an excess of acid over base, so that pH remains relatively low. What's going to happen is, I get close to my endpoint, and then all of a sudden it will skyrocket. It'll go from a very low pH to a very high pH in a matter of a couple milliliters. It's going to be a very abrupt transition from an excess of acid to an excess of base. If I have a strong acid and a strong base at the equivalence point, which would have a pH of 7, and it would be a neutral substance. So this is the equivalence point, and then it still continues to go up abruptly, but then it starts to level out as my OH concentration is higher at the end right here. So we're going to look at the calculations and then come back to this titration curve for a strong acid, strong base. This corresponds to section 15.4 in your book. There's actually a number of different titrations in here, and we're going to make this a little bit bigger and look at this more closely. So I take what's done in this section, but I try to break it down and simplify it a little bit. They do a lot with millimoles. I don't. Okay, I think it's easier to not work with the millimoles. So you'll see how I do my calculations in these amounts, and it is the same calculations, except I'm trying to condense it and help you keep track of things. So we're going to have a strong acid titrated with a strong base, and it looks like I have 50 milliliters of 0.2 molar HNO3 titrated with 0.100 molars of NaOH. So when am I going to reach the endpoint? When I have equal moles of acid and base. Because my base is half as concentrated, I'm thinking I'm going to need twice as much volume. Okay, you could voom or do MAVA equals MBVB to solve that, and this endpoint should be at 100 milliliters. You can still titrate beyond the endpoint if you choose to. All right, so the initial pH of a strong acid, if it's 0.200 molar, doesn't matter how much we have of it. I take the negative log of that, and I get 0.699. All right, now what about after I add 10 milliliters of NaOH? Okay, so this just becomes like an excess acid, excess base problem, and I think we did this back in the last unit. And you can go through dilution factor. I almost think it's easier to just compare moles to moles and divide through by total liters. So I take the 0.0100 liters, that must be the 10 milliliters of the OH that I added, and I multiply that by the 0.100 moles per liter. I get 0.0010 moles of OH minus, and I take my base, or my acid, which is 0.050 liters, times a 0.200 moles per liter, and I get 0.0100. Well, I subtract, I find 0.0090 moles excess H plus. I divide that by the total liters. Okay, so I divide it by the 50 original and the 10 I added, and I get H plus is 0.15, and it still is highly acidic at 0.82. Okay, I could do the same thing at 20 milliliters, and if I do that, let's slide this up, I'm going to get 0.0020 moles here. So I have 0.0080 moles excess, but notice it's over 0.07 liters, right? Because I have 50 plus 20 liters added, and it's 0.94, not affecting the pH much. Okay, let's say I add 50 milliliters, 0.005, 0.0100, 0.005 divided by 0.1, I get 1.30, still not affecting the pH much. Let's say I get to 100 milliliters added, okay? Well, now I have equal moles of H plus and OH minus, so that is our midpoint, or endpoint. I'm sorry, that's our equivalence point of moles of acid equals moles of base, which is 7.00. Okay, let's say I kept going and I added more base, okay, beyond my endpoint. So now I have an excess of 0.050 moles of OH minus. I divide it by total liters, and I get this pH. And if I kept going up to 200, you can see the calculations, and I get 12.6. So it's starting to tail off and level off right here as I have that excess of base. All right, so everything except where you have actually the exact amount of moles of acid and moles of base makes it neutral. Otherwise, all of these are like an excess acid, excess base problem. Less than 100 milliliters of base added, you have excess acid. More than 100 milliliters of base in this case, you have excess base. Let's just go back and look at our titration curve. I'm going to shrink this up just a little bit. And notice I have my points in this titration, okay, and I draw these different points in just to emphasize this would actually, if I had the 4 right here, it would probably be a lot closer to 100 right here. So as I drew this over, it would almost be perfectly vertical, a very small movement in millimeters from 4 to 10 on the pH scale, like maybe a movement of 1 milliliter, and you're going to get this huge jump in pH right there. So it's drawn pretty well to reflect that, but you'd even see that even more steep at this point between 4 and 10 right here. And then it starts to veer off in that direction. All right, this is a titration curve for a strong acid titrated with a strong base. I'm not going to do a strong base with a strong acid, but you could expect a similar starting thing where you'd start with a high pH, it would gradually drop, and then it'd drop way down, and then it'd start to level off like this. So again, strong base titrated with a strong acid would be kind of the inverse of that type of thing, with a very steep range when you are converting from base to acid. Just like this is a very steep range in pH when you go from acid to base. It happens very, very quickly. All right, thanks for watching.